Right, welcome to question 6 of the Year 10 end of year exam. Question 6 is going to be about structure and bonding, and we need to complete the dot and cross diagram to show the covalent bonding in a nitrogen molecule. Show only the electrons in the outer shell. Right, to do dot and cross diagrams, first of all we need to establish how many electrons are in the outer shell of each of the atoms that we're talking about, and both of our atoms here are nitrogen. So we're going to go to our periodic table and we're going to find nitrogen. There it is. It's in group 5, so it's got 5 electrons in the outer shell. It's got 5 electrons in the outer shell. The magic number it needs to get to is 8. So to get from 5 to 8 it's going to need to share 3 electrons. So the first thing we're going to do is we're going to put 3 crosses for the 3 electrons from this nitrogen. If it's going to share 3 out, it's going to get 3 back. So there are another 3. We use a different symbol for electrons, even though they're the same particle, to show where the electrons come from. So this nitrogen, we've accounted for 1, 2, 3 of its outer shell electrons, but we know because it's in group 5 that it's got 2 more. So we put those 2 more in there like that. So it's now got 1, 2, 3, 4, 5 electrons of its own, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 8 electrons in total in its outer shell, so it's happy. We go to the other nitrogen, we've accounted for 3 of its electrons, 1, 2, 3, but we know it's got 5 in total as well, so we put the other 2 there. So we've completed, that's enough for your 2 marks, but just to remind you that each pair of shared electrons is a covalent bond. So if we were to draw this bond out as covalent, as just a simple covalent bond, we're not asked to, but if we were, it would be like this. We'd have the 2 ends, and it would be 1 covalent bond, 2 covalent bond, 3 covalent bonds, making a triple bond. The next part of the question says, explain why nitrogen is a gas at room temperature. Answer in terms of nitrogen's structure. Well, this is nitrogen. We've just drawn it. It's a nitrogen molecule. Okay, you were told that. Show the covalent bonding in a nitrogen molecule. The question says, explain why nitrogen is a gas at room temperature. Well, if things are a gas at room temperature, it means at room temperature they've already boiled. They've already turned from a liquid into a gas. So what this question is really asking is, why does nitrogen have a low boiling point? Why does it boil at a low temperature? Now, you know that to boil something, you have to break the forces between the particles in it. Now, the question is, what are the forces between the particles, and what are the particles? Well, nitrogen is a simple covalent molecule. It is a lot of nitrogen atoms joined like this. Whoops, that one wasn't very joined. Just like this one here. So we've got a very strong covalent bond between atoms, but look, there's nothing between the molecules. There are no bonds between the molecules. The forces between the molecules, the intermolecular forces, are extremely weak. As a result of that, it doesn't take much energy to break those intermolecular forces, and as a result of that, it's very easy to boil simple covalent molecular substances like nitrogen. So how are we going to answer this question? Because it's worth big 3 marks. Nice, lovely 3 marks. What could we say? Well, I'd start it off right by saying, just affirming to the examiner that we know what we're talking about. Nitrogen consists of simple covalent molecules. Here they are. Simple structure, 2 atoms joined to one another to make a molecule. And then now we go on to say, to boil nitrogen, intermolecular forces between nitrogen molecules need to be broken. So I've explained to the examiner I know what boiling is about. Then I would say the intermolecular forces in nitrogen are weak, as discussed. There are no covalent bonds between molecules. So, therefore, little energy is required. So, therefore, boiling point is low. Therefore, nitrogen is a gas at room temperature. Right, there is no way that the examiner can't give you 3 marks for explaining right back from first principles why nitrogen is a gas at room temperature there. Turning over. Another juicy structure and bonding question for 4 marks. Graphite and fullerenes are forms of carbon. Graphite is soft and is a good conductor of electricity. So we're given two two conditions there, with two properties. Explain why graphite has these properties. Answer in terms of structure and bonding. So your command word is explain, and you're being told that you need to explain using talking about structure and bonding. Now, the way I would approach this is to do subheadings. Okay, I would first of all do a subheading structure and bonding. I didn't do it very well, but there you are. I've got structure and bonding and underline it. And then I'd go on to talk about the structure and bonding in graphite that I know all about. And I'd say that graphite is made of carbon atoms, each of which is strongly covalently bonded to 3 other carbon atoms. So here's my carbon atom. It's got 3 covalent bonds to 3 other carbons, like this. And you can see that that makes up sheets of hexagons. Remember the hexagon shapes? So 3 covalent bonds to 3 other carbon atoms, making a sheet of hexagons, sheets of hexagons. The 4th bonding electron, because carbon is in, remember, group 4 carbon, so it's got 4 electrons in the outer shell. The 4th bonding electron is delocalized, and it sits between the hexagon layers. So I've done the structure, and I've probably got my 2 marks for structure and bonding, explain the structure and bonding of graphite. Now I'm going to address why does it conduct electricity. Well, I'm going to say because of those delocalized electrons, graphite has charged particles that are free to move and conduct electricity. Why is graphite soft? Well, it's soft because these layers of hexagons are only 1 atom thick, and the forces between them is only that delocalized electrons. That means, because of its layered structure, the sheets of hexagons can slide easily over one another. 4 marks. Really important that we can answer our structure and bonding questions because they are guaranteed to be on the paper. 6.4 shows a model of Buckminster fullerene. Buckminster fullerene is a special form of carbon. It's also a nanoparticle. A lubricant is a substance that allows materials to move over each other easily. Suggest why Buckminster fullerene is a good lubricant. This is an example of a question where they're expecting you to use a little bit of knowledge that you have. You have Buckminster fullerene, its existence is on the course, but we don't really talk much about it. It's asking you to think why it would be a good lubricant. It's worth 2 marks. And the first thing to say is it's a ball. It forms a sphere. It's a spherical shape. Spherical, if you don't like the word spherical, is ball-shaped. And very simply, balls can roll over one another. And if you can roll over one another, you are a good lubricant. It's like stepping on a plate of marbles. Next question is about nanoparticles, and it's a calculation question. It's asking you whether you can do a surface area to volume calculation. So it says a silver nanocrystal is a cube of side 20 nanometers. Calculate the surface area to volume ratio of the nanocrystal. This here is irrelevant. It's kind of just put in to confuse you, I'm afraid. The only piece of key information is it's 20 nanometers and it is a cube. Therefore, if we've got a cube, 20 by 20 by 20, like that, 20 tall, 20 wide, 20 deep, we can work out its surface area. The surface area of one face there is 20 by 20, but because it's a cube, it's got 6 faces. It's got 1, 2, 3, 1 we can't see there, 4, 5, and 1 underneath is 6. A dice has 6 faces. There's 6 numbers on a dice. So the total surface area is 20 by 20, which is the surface area of one face, times 6 faces is 2,400. That's the surface area. The volume, on the other hand, is easier. It's just 20 by 20 by 20. 20 by 20 by 20 is 8,000. That's 1 mark. That's the second mark. The third mark is for making the ratio, and we had to be quite has to be done in the exact way for the examiner. So we're going to get the ratio. We're going to divide the big one by the small one. So we're going to divide the surface area, the volume by the surface area. So we're going to get, and remember what we've got there. So the small one is the surface area, the large one is the volume. So what we're saying is the volume is 3.33 times bigger than the surface area. So we're going to, it's asking for the surface area to volume ratio. So the surface area bit comes first, that's the 1, and the volume comes second, that's the 3.3. Okay, in a ratio, if you're giving a ratio answer, one of the numbers has to be 1. That's what the simplest form of the ratio, one of the numbers has got to be 1. So it's 1 to 3.3. If you did the calculation the other way round, they would have accepted 0.3 to 1. So that's just the doing 2,400 divided by 8,000, that would give you 0.3. So then it would be 0.3 to 1. But again, one of the numbers in the ratio is a 1. Final question in question 6. Silver nanoparticles are sometimes used in socks to prevent foot odour. This is the classic example of nanoparticle use. Silver is quite a good antibacterial agent in small amounts. Suggest why is why. Why is it cheaper to use nanoparticles of silver rather than coarse particles of silver? And the mark scheme is extremely strict about this. It wants you to understand that the surface area, so the active area, the area available to react of nanoparticles of silver is far greater than in coarse particles. So that's the first point for the first mark. And want you to understand that the advantage of nanoparticles is much bigger surface area, so much bigger area of chemical to react, available for it to collide, to produce a successful collision. The second mark, therefore, is to say, well, if it's got a higher surface area, I don't need as much of it. Less silver can be used to produce the same antibacterial effect. That was 16 marks. That's almost a grade boundary and a half. So when you're doing your revision for the exam, structure and bonding is a hugely important unit, and you really have to be sure that you've got the principles, ionic, covalent, metallic bonding absolutely nailed.